Swayam Prabha. Digital India. Educated India.
Hello my dear students, welcome to Swayam Prabha. Course title Pharmaceutical Organic Chemistry 2. Lecture title Benzene and its derivative. Module number 1, lecture number 4, and lecture ID M1L4. So myself, course coordinator, Mr. Dhamak Vikrant Muralidhar, affiliated to Savitribai Phule, Pune University. Name of academic expert, Dr. Sunil V. Amrutkar. Project name DTS Swayam Prabha, sponsored by MHRD, New Delhi. So firstly, we will see learning outcomes of this session. To study synthesis and reaction of benzene. To study structure and uses of some important benzene derivatives which are important pharmaceutically. So now let's see the contents of this session. So the first content, that is preparation methods of benzene. So as per the syllabus is concerned, so we will look around 5 preparation methods of an benzene. And after that, reactions of benzene. So already this part has been covered. So again we will summarize that reactions of benzene. So we, in the earlier session, we have seen about some reactions of benzene with a mechanism like sulfonation, halogenation, Friedel-Crafts acylation, alkylation. So such kind of reaction again they will encounter. So we will see in the summarized form. And after that, structure and uses of some important derivatives of an benzene which are commercially being utilized on the large scale, and pharmaceutically also they are important and they are utilized in the pharmaceutical industries like DDT, BHC, chloramine T, and saccharin. So here it has been given in the short form as commercially it has been known. We will see whole structure and whole name of that compound, what it actually means. So moving towards the first part, that is preparation of an benzene. So benzene, we have discussed in 5 methods over here, how benzene it has been prepared. So the first method, it is from petroleum. So petroleum, it means an hydrocarbons. So from hydrocarbon, benzene can be synthesized, and allied derivatives of an benzene can be synthesized by increasing number of an carbon with an hydrocarbon. So the number of carbon will decide what type of a derivative it will form. So the first reaction, that is N-hexane. So N-hexane, it is a straight chain compound, and when it is been heated with platinum and aluminium trioxide at 500 degree and 15 atmospheric pressure, so it forms an benzene. So platinum, it is an catalyst over here, as well as an aluminium trioxide, it is also a catalyst. So this reaction, it is carried out under a drastic condition. So drastic in sense that this reaction conditions are in a very tight container, because heating the compound at 500 degrees Celsius, so it forms a gas. Easily hydrocarbons can be converted to an gas, because they are having almost an low boiling points. And this all it is done in an done at an 15 atmospheric pressure. So all these things, they are done in a closely tight vessel, and this kind of reactions are carried out in pressure reaction vessel. It's just like a cooker, and so in that reactions are being carried out with such kind of conditions. If we increase the number of an carbon, so here we can see that number of carbon has been increased. So now it's a structure of an N-heptane, and with the same reaction conditions, so it can be converted to an toluene. So it is one of an derivative of an benzene, and with increasing of an carbon, so one more derivative of an benzene, it can be prepared. So as we increase the number of a carbon over here, so one more derivative of an benzene, it can be formed. Second method, it is from acetylene. And acetylene, so simply the acetylene, it is passed through an hot red tube. So acetylene, it is a gas. And commercially, acetylene gases are being utilized for ripening of fruits. In the earlier days, it was been fruits were kept in the pot, earthen pot, and acetylene gas, it was been forming, and it was responsible for ripening of fruits. So this acetylene, it is an alkyne structure. So alkyne, it is having a 3 bonds, out of which 2 are pi bonds and 1 is sigma bond in between. So it requires 3 moles. So 3 moles are required to form an benzene. So all these 6 carbon, they will adjoin by donating an electron towards an carbon, and this one of an pi bond, it will break, and it will form an this pi bond, it will form an sigma bond. So here you can see that how it breaks. So the bond between carbon and carbon, it will break. So one pi bond, it will this breaking, it will be an heterolytic, and this heterolytic breaking, so it will make one carbon electron rich and one carbon electron deficient. So one will be electron rich and one will be an electron deficient. So the deficient carbon, that will again adjoin with an concerning structure. So this carbon, now again it will again form an electron deficient center and electron rich center and electron deficient center by breaking of the pi bond. And now this two will adjoin to each other. Adjoin means the electrons over this carbon, it will be donated towards an electron deficient carbon. And after that, again the same thing, it will be happening, that electron rich center from this side, it will donate an electron towards this electron deficient center, because the bond between this carbon carbon is now breaking, and it will again form electron rich center on this carbon, and this will be an electron deficient center, so which will be joined with an electron rich center. And this one carbon, it is an electron rich, so it will join with an electron deficient center. So this happens, and this happens at almost at 500 degrees Celsius or 873 Kelvin. And after that, benzene, it has been formed. Second one, that is from an sodium benzoate. By heating benzoic acid or its sodium salt with soda lime. So soda lime, that is mixture of NaOH plus calcium oxide. So either benzoic acid it has been taken, or sodium benzoate. So it is an ester form, and when it is been heated with soda lime, that is NaOH and calcium oxide, so it forms an benzene. So very simply, it forms an benzene, and so in this case, decarboxylation it has been observed because carboxyl group it has been dissolved or it has been removed out, and CO2 it has been formed from this such kind of a reaction. And one more product does we get, that is Na2CO3. So by combining all this, we get an sodium carbonate. So now next method of preparation of a benzene, it is from phenol. So phenol, it is heated with zinc dust. Phenol, after heating with an zinc dust, it forms an benzene. So it is one of a simple method, giving away an zinc oxide, a byproduct. Next method, that is it is from an chlorobenzene. So such kind of an reaction in reversible way we have seen in halogenation of an benzene. So again, from halogen, what benzene has been prepared. So benzene can be reversely prepared from an chlorobenzene by treating chlorobenzene with an magnesium followed by a treatment with a dilute HCl. So chlorobenzene it has been treated with an magnesium foils, and after that it forms an in between, that is a Grignard reagent. So this phenyl magnesium chloride, again it is treated with a dilute HCl, and due to which it removes magnesium chloride from a phenyl ring, and now it forms a benzene. So here magnesium, it is actually a metal, and this metal, when it is living away, so it carries an electron deficient center, and it gives an electron towards this benzene, and due to this phenyl ring, it becomes an electronegative, it becomes an electronegative, and hydrogen or proton from this acid, it will now interact with this center, electron rich center, and it will form an benzene. So simple, that is Grignard reagent, it has been utilized. Now after that we will be looking for reactions of an benzene. So already we have discussed this topic in earlier session also, but I am summarizing it because syllabus has given this topic, that reactions and synthesis of an benzene. So just we will overlook the session. So by using of a nitrating mixture, that is HNO3 and H2SO4, so benzene can be nitrated and it will form a nitrobenzene. So for generation of a nitronium ion, H2SO4 it has been required. So without that, it does not form an nitronium ion. So H2SO4 it is required for a nitration. After that, sulfur trioxide and H2SO4, so it forms an benzene sulfonic acid. After that, by using often some Lewis acid like FeCl3, so chlorine gas, it has been reacted with an benzene and it forms an chlorobenzene. So such a reversible reaction also we have seen in case of a synthesis, that it is treated with an magnesium foil, and that magnesium, it is sequentially product whatever magnesium it has been forming, it has been treated with an dilute HCl and it forms an benzene. So at both ends this reaction is important. So halogenation of an benzene can be done by using of an this FeCl3, that is Lewis acid. It forms an chlorobenzene, and again by such kind of a reaction it is said to be an Friedel-Crafts alkylation, because alkyl group or R group, it has been introduced on the benzene ring by replacing one hydrogen, and it is done, this operation it is done with an ALC like reagents like an AlCl3. So Lewis acid, so these are Lewis acid, and with this Lewis acid such kind of an operation can be done for introduction of an alkyl group at an benzene ring. After that, similar kind of a reaction uh, of an Friedel-Crafts alkylation. Second is Friedel-Crafts acylation. So in case of an Friedel-Crafts acylation, it forms an ketone. That ketone, it is an aromatic ketone, and it has been substituted by an R, and one side it has been substituted by an phenyl ring. So such kind of a reaction they are called Friedel-Crafts acylation, because acyl group it has been introduced, so they are said to be an Friedel-Crafts acylation, and this is done with the help of an Lewis acid. So in both the cases, Friedel-Crafts acylation and alkylation, so Lewis acid it has been utilized, and also in case of an halogenation, Lewis acid it has been utilized, and another reagent which is needed for an introduction uh, or or on benzene for an substitution. So all such kind of reactions they are an substitution, aromatic substitution reaction. So whatever we have completed in the earlier session also, that uh, every hydrogen from each and every reaction, hydrogen it has been replaced by another reagent. So these are the five reactions of an benzene. After that, we will look for an first derivative of an benzene. So the first derivative, that is diphenyl trichloroethane, and it is shortly called DDT. And why it is dichloro? See here you can see a dichloro at both the phenyl rings, and after that this diphenyls, right? This diphenyl they are been combined with an trichloroethane. So trichloroethane means carbon number 1 and carbon number 2. So it forms an ethane structure, and this carbon number 2 of an ethane, it has been again substituted by 3-chloro. So it means a trichloro. So instead of using an very much full form of this compound, so uh, it it is recognized by a DDT simply. So this is a structure of an DDT, and there are some uses of an DDT. So it was very beneficial to control malaria and typhus in World War II. So it has controlled malaria and typhus. And after that, after World War, after 1945, so malaria, to eradicate malaria, WHO thought to use DDT to eradicate malaria completely from the world. So that operation was carried in 1955, and later on, so it was and utilized an pesticide, or we can say an insecticide. So because it was used for an pest control over an uh, in the sector of an agriculture, and heavily it has been utilized till 1980s. Later on it has been banned in lot many countries because it is having lot many side effects, and due to which it was been banned later on. After that, coming towards an word saccharin. So saccharin, it similarly similar to an sugar like, but it is not an sugar. So this, it is an heterocyclic structure, a saccharin. So it has an abundant uses because saccharin, it is an sweetener agent, and commercially it has been utilized for sweetening foods and beverages without calories, and it has a sweetening test more than sugar. And how much it is? It is 500 times. So it is very high, and that is why the saccharin, it is been utilized, and it is without the calories. So that is an important thing, and that is why it has been utilized for an anti-diabetic patients also, and also with the weight conscious patient, because whenever it is an calorie free or whenever it is said to be an sugar free, so it means that it will not affect the body, or it will not increase in glucose level in an blood. And that is why saccharin, it has been utilized as a sugar free drug for a diabetic patient and a patient which are conscious with an weight. It is also used as a sweetening agent in toothpaste, mouthwashes, and aerated drinks. So aerated drinks, it means the drinks that like Pepsi or Thumbs Up. So such kind of drinks with an carbonate are said to be an aerated drinks. And in case of a toothpaste also, this saccharin, it has been found, and mouthwashes. So in case of an gargles, it has been utilized. So there are a lot many uses of an saccharin, and abundantly it is used in pharmaceutical sector. Again, one more compound commercially which is called BHC, and there are also some name for this BHC. So one of a name that is linden. There are some other name also, so I have not focused on it. And so it is having a structure that all the hydrogens on a benzene, they are being replaced by an chlorine. So BHC is an important agricultural pesticide and mainly used for exterminating white ants, leafhopper, termite, etc. So these are some kinds of an insect. Also, it is used in treatment of head and body lice, and it is used to treat scabies, and due to its antibacterial properties, so it can be used to treat scabies also. Also, it is used in shampoos. So these are some uses of an BHC, that is benzene hexachloride. After that, chloramine T. Some syllabus has said that chloramine, so actually it is an chloramine T. When it comes to an chloramine, so structure of an chloramine, it is different, and chloramine T, it is different. When it comes to an T, it is having an benzene ring in the between, and when it is only an chloramine, it is an alkyl halide type of compound. So it is also said to be a sodium salt of N-chloro-paratoluene sulfonamide. So this is a structure, and why it is said to be an paratoluene sulfonamide, N-chloro-paratoluene sulfonamide, because here you can see the structure, it is of a toluene, right? And this toluene, it is at para position or position number 4, so it is said to be an paratoluene. And after that, this sulfonamide at 4 number position, so it has been substituted by an chloro at N position, and here you can see it is a sodium salt. So it is said sodium salt of that N-chloro-paratoluene sulfonamide. So sulfonamide, it is one of a category in antibacterial category, a very effective antibacterial category. So chloramine T, it is a strong oxidizing agent. It is used as antibacterial and anti-disinfectant. So antibacterial properties of an chloramine T, it is due to this sulfonamide moiety. So these are responsible for an DHFRS inhibition. So dihydrofolate reductase. So it has been stopped by this sulfonamide moieties. And it has an ability to react very fastly, and due to which it is used for labeling peptides and protein isotopes. So this chloramine T can react very fastly with an iodine, and such kind of an product they are being utilized for labeling of an peptide and protein isotopes. Now we'll see summary of this session. So at very first instant we started with preparation methods of an benzene. So there are 5 ways to prepare benzene what we have discussed in this session. So first one, it was from an petroleum, so hydrocarbons especially, uh, with the use of an platinum and aluminum trioxide. It is been heated at 500 degrees Celsius and at having an atmospheric pressure up to 15. So by increasing chain length of this hydrocarbon, we can get some more derivatives. So we have seen an example of an toluene also with an heptane, and certain like ethyl benzene, we can increase one more carbon. Either using of an heptane, we can go towards an octane. Either we will get a xylene or we will get an ethyl benzene. After that, we have seen a reaction that in a hot red tube of an iron, acetylene gas, it has been passed at 500 degrees Celsius or 873 Kelvin, and 3 moles of acetylene are been required to form an benzene. So all these 3 moles they will combine by heterolytic fission, and they will make an electron rich and electron deficient centers, and after that they will combine, and this combination will lead to a formation of an benzene with an alternate structures. After that, we have seen from an chlorobenzene. So by utilizing an magnesium and dilute HCl. So in the first step, it has been magnesium. It has been added magnesium foils, and after adding of an magnesium foils, it forms an like Grignard type of an product or reagent, and after that it has been acidified with water and acidic water, and it forms an benzene. After that we have seen phenol. So phenol, when it has been heated with an zinc, so it forms a benzene plus zinc oxide. So very simple reaction. And later on we have seen the last reaction from preparation of benzene method, that is sodium benzoate or benzoic acid. It is being heated with an soda lime and it forms an benzene. So these are the 5 preparation methods that we have seen in this session. After that we have seen reactions of benzene. So I will not discuss a lot much because already we have seen in the earlier sessions also. So first one, that was nitration. After that sulfonation, forming an benzyl sulfonic acid. After that halogenation by use of an Lewis acid with the help of an chlorine gas. And after that Friedel-Crafts alkylation, so introduction of an alkyl group on an benzene ring with the help of an Lewis acid. And after that Friedel-Crafts acylation with the help of an Lewis acid once again. And these are the 5 reactions of an benzene that we have seen. After that, we have seen some important derivatives of an benzene. So first one was DDT, dichloro-diphenyl trichloroethane, having 2 phenyl rings substituted with an chloro, and in between it was having an ethane, which was been substituted by an trichloro. So we have seen the structures and uses of respective. Secondly, we have seen lot much important component, that is saccharin. So it is more sweet than in sugar, and it is free of calorie. After that, we have seen BHC, that is benzene hexachloride, and we have seen the structure and again the uses of this benzene hexachloride. And after that, we have seen a chloramine T. So it is also been utilized for labeling of isotopes. So these are the four derivatives we have seen. So thank you. We have completed module number 1 and lecture number 4. So lecture ID M1L4. So totally benzene and its derivative module now we have completed from this lecture. So after that, this session we will have an next module. Thank you.